Hello everyone, welcome to today's video. This video is prepared by AIAS and this is going to be our tutorial over using QGIS to develop accurate existing topographies within AutoCAD or Revit. The required applications you'll need are QGIS, um, AutoCAD if that's what you want to import it into, or Revit if that's what you are using it for. You will also need the USGS TNM download V2. This is the United States Geographical Services, and this is where they store all the 3D topo maps for the entire United States. And so as an example of how to use these tools, I'll be using a very common tool or a very common site, sorry, that you will encounter a lot at SIU, which is the site just north of Quigley, where there is a substantial amount of elevation change and some interesting uh, turns to the topography. And so on USGS's TNM download V2, what you're going to want to do is you want to zoom in on your site. So for this, we're going to want to go to Carbondale, which is here. And we are going to select elevation products and hit this blue search products. And what this will do is this will take this area and search for the products that relate to it. In this case, we have a TIFF file that relates directly to Carbondale. And to give you an idea of how big these TIFF files are, it's an entire section of multiple counties, including Cape Girardeau. So whenever we work on this TIFF file, we're going to need to make sure that we're very concise with what we want it to draw. Otherwise, if you don't, you might be drawing topo lines for every piece of elevation between Carbondale and Cape Girardeau, which is not very good on your computer. So when you get to this part and you have your TIFF file, you would hit the download link in parentheses TIFF, and that will start downloading the TIFF file. I have already downloaded the TIFF file just so to make this process go a little bit quicker, and we can carry this over into QGIS. When you start up QGIS, this is how it's going to look, except your project files are going to be empty. What we're going to want to do is we're going to click Project and click New. And then we'll have just a white screen, and underneath XYZ tiles, we can double click Open Street Map, and it will open up Street Maps software, and we can then zoom in on Carbondale specifically, since that's where we're working in. And we can see here's Quigley, and here is the site that is sometimes used in our projects. And so what we're going to do is we're going to click on Layer. Actually, before we add layers, one thing we're actually going to want to do is set the CRS of the file, and so of the project. So CRS is just your coordinate reference system. I find that the CRS, the WGS 1984 Web Mercator auxiliary sphere, allows me to create these 3D topographies the easiest. And so make sure it has just this authority ID on it, and you can search for it in the data in QGIS's database. But I find that this is the one that works the best, and we're going to hit apply and OK. And so now this is your coordinate reference system is simply just the set of data for different elevation products. And I find just this one works best for these types of projects. So now what we're going to do is we're going to go to Layer, Add Raster Layer. And what we're going to do is we're going to click on these three dots and find the TIFF file that we downloaded. And it will locate it in your files. And then we can click Add. and then find whichever one is the most accurate. This 1.5 seems to be pretty accurate, so we'll just go with that one. Hit OK and close. And now we're also going to want to close out this tab. And so now we got just this gray screen. And so what this is this is the TIFF file of all the topography all around Carbondale. So what we're going to want to do is I'm going to want to catch pretty much everything from Quigley Hall, let's say up to the hangar and over here in the rec center. And so what we're going to do is once we've inserted this raster layer, we're going to go to raster, extraction, and clip by raster extent. And what this will do when we hit this button right here, it will clip this boundary of our window to make it to where this is all the TIFF file that's going to remain. And that's going to make sure that we're not drawing topo lines all the way down to, say, Cape Girardeau and Carbondale. So we're going to hit that and run. And then we're going to close our other layer because we don't need to see that anymore. When we zoom out, now we got a topography of just this portion of Carbondale. And then after we do that, we are going to want to go to raster again, extraction, and this nice little button says contour. And then we are going to want to set it to our clipped extent. And basically, QGIS is a software that was developed in Europe, so everything is on the metric system, and it is set to every 10 meters because this was made for large-scale topographies. However, for us, since we do everything in feet, what we're going to want it to do is we're going to want to put in either 0.3048 for every 1 foot, because that's how many feet are in 10 meters, or 3.408, which is 048. Which is every 10 feet you put a topo line. But for the sake of accuracy, we're going to, on such a small project, we're going to do 3048 for every 1 foot. And then we are going to run this. So now we got contours of all of this area of Carbondale, and as you can see, it pretty accurately represents those hills that kind of extend out, and then you have the Welcome to Carbondale SIU campus sign out here that's sitting out a little bit higher up, and you have that deep well there in the site. So we know this is fairly accurate for what we want for our site. And so now we are going to go to Layer, Create Layer, Create Shapefile, and then we are going to need to set its CRS to be the same as our project, geometry type, polygon, and we are going to name this temp layer. And then we're going to hit OK. And then we're going to bring that a little bit above, and that'll make sense here in a second. So on our temp layer, we're going to select that, select the pencil, and then the add polygon feature. And what this will allow us to do is draw where more specifically we want this site to be. So let's say your professor wants you to include this parking lot, Woody Hall, Quigley Hall, and maybe part of the train tracks. And so we're going to go from Woody Hall over across the train tracks up to the top of the train tracks and all the way out to these first buildings of the downtown area here. And then what we're going to do once we left click all 4 of those, we're going to right click and type 1 whenever it asks for its ID. Hit OK. So now we got a temp layer showing where we want these lines to be cut at, and it's on a shapefile layer, so now it can actually start taking shape. And so now we are going to go to vector, geoprocessing tools, and clip. And what we're going to make the input layer is our contours. The overlay layer is our temp layer. And then we're going to say clipped topo and run this. Should be all right. Clipped. Okay, it's going to be like that. Okay, so if you just leave this empty and hit run, it's just going to name it clipped. Apparently, it just didn't want to run it with a name. But we will come out with just the topo lines for this small portion of Quigley Hall and Woody Hall. And so once we do that, we are going to right click our clipped layer and export feature as, and we're going to make sure it's an ESRI shapefile layer. And then we are going to make sure it's on the correct CRS, and this is going to be clipped topo, and we are going to hit OK. So now we got a saved shapefile layer, and every single time I do something new, I like to hide the old stuff so that way I don't get confused as to what I'm working on, and just keeping it as clean as possible. So now once we have it set, we are going to go to our plugins. And one thing that you're going to do is you're going to manage and install plugins. And we're going to go down to Grass. I already have Grass installed, Grass 8, but you're going to need those tools, and that's what's going to help us create these 3D topo lines. So once you go to, once you download that, the tab will appear here, and you'll hit New Map Set. I don't care where it really saves to. I'm going to call this Carbondale. Next. Make sure it's on our correct CRS. Next. Map our canvas extent so that way it's focusing on this region. And we're going to call this Quigley Project. Next. And finish. And it'll let you know that you've successfully created a map set. Then from there, we're going to go to our grass plugins, open grass tools, at which point we'll be given this set of parameters over here. So once we have this made, we're going to go to File Management, Import into Grass, Import Vector into Grass, and we're going to click on this top result here, v.in.org.qgis. And then the layer we wanted to select is clipped topo. That's our save file layer. And we're going to name this. We're going to go topo grass and hit run. Now, initially, it won't show up here. That's okay. You have to hit view output, and then we can hide our other lines. And there is our topo grass file. And after we do that, we are going to go back to modules. We are going to go to vector, develop map, convert 2D to 3D by sampling raster, and then we are going to select this last one here, v.to.3d.attr. And once we select that, then we're going to put the input as topo grass. Then we're going to name this topo grass with height, and we're going to set that to elevation. And then once we do that, we can run that and then view output again. And now we should have a 3D topography to now export into whatever program we like. So for the sake of it, I'll start opening up AutoCAD. And while that's opening, I am going to export project to DXF. Make sure the only thing selected is the topo grass width height is my last layer that I created. Make sure the CRS is set correctly. And I would like to save this somewhere a little bit more easy to find. So I'll go straight to my downloads with it. Topo demo is what I'm going to call that. Hit save, and we should be able to hit OK with this. And so now we should have that exported to AutoCAD. And so now if we go to AutoCAD and we open, let's go to desktop, downloads, and topo demo. Now when we open this up in AutoCAD, we can pull this down and we can see we now have a 3D set of lines. Now the other thing that's a little bit weird about this program is sometimes it does not export them at the correct scale. So when we go back into QGIS, we can take some fairly easy to find out dimensions. So let's set this to feet. We're going to go from here to here on this piece of topo. And so we know that that needs to be 121.358 feet. And so if we go in here and we hit measure distance, we measure that. It's unitless currently, but this should be in feet. And that's what I'm going to do is I'm going to set this 2 feet. So let me go to units, type architectural feet. Okay. Okay. So measure distance. So it's 3 feet, 10 and 5/8 inches currently. So if we go back to this, it should be 121.358. And so in order to get those to match, we got to divide the one we want it to be, which is 121.358 by what it currently is, which is 3 foot 10 and 5/8. Let me figure out what 5/8 is in decimal form. Actually, it's 6.25. So 10 plus 6.25 divided by 12. Sorry, 10.625 divided by 12 plus 3. So this one is currently sitting at 3.8854. And so the 121.358 is going to be divided by 3.8854. Hit enter. Okay, so that's going to give us the scale factor for this needs to be, we hit SC space, specify a corner to make it easy on ourselves, and then 31.23436. Enter. And so now if we measure this again, it should be 121.35 roughly. Yep. So that's all now to proper scale. And so whenever you try and place your project on this existing site, it should line up 1-to-1. And so to make it easy on myself, I'm going to save this as continuing to save it as a DXF file. Topo demo scaled. Okay. So now that all this is properly scaled, we can now open up Revit. And what Revit will allow us to do is essentially import or link this AutoCAD. And once the AutoCAD is linked, we can then use Revit's built-in tools that allow you to create a topography out of an AutoCAD. Now this is usually made for civil engineers that take topo surveys of sites and then give it to you in the form of an AutoCAD. But this at least allows you to create very reasonably accurate existing topographies much quicker and on demand whenever you need them, and you don't have to be reliant on someone giving it to you later. So I get rid of this, and this opens up entirely because it is slow. I'm going to create a new project. Once we get into that project, I'm going to jump right into the default 3D view and hit insert. We are going to link a CAD and not a topography because it's technically still a CAD file and it won't recognize it as a straight up topography. And then we're going to go to desktop, downloads, topo scaled. We're going to open that up. And now our topography is in here. We're going to have to unpin that. But now we can go to massing and site. Under TopoSolid, create topo from import, hit create from CAD, and click on this. We're just going to make sure that the topo with grass height is the only thing selected. Hit OK. And if we enter realistic view, we have a pretty accurate topography of this entire site outside of Quigley. The only thing I will mention is in order to modify this topography, you have to modify sub-elements, and it basically chooses kind of at random what lines they're going to put these topo points, and so it's going to look like a weird mesh when you enter that mode. And then you might also have to put points over here where the topography ends to make it look kind of whole. And the other thing is, if you wanted to do this, but make it smooth, you can use Rhino and basically do the exact same thing where you just import, just type import CAD, and then you export it to it. In fact, I could probably just show you because Rhino doesn't take forever to launch. But it'll allow you to import the AutoCAD and then create a surface out of it by using some commands to basically connect each of the lines individually, and it will create a smoother project, and you can then import that into your Revit. So import topo scaled, open, feet, inches, correct. So once you hit that, it does a weird thing where it kind of throws it into a random space. So if we hit this tool, it'll show where it's at in the file. So what we're going to do is we're going to move this back to where it belongs. And we're going to select this, and we're going to type 0, 0 to move it back to where it belongs. And there we go. That's where the starting location is. And then once you bring it in, I believe the command is to select it, and then I think it is, I'm trying to remember what the command is. It's under surface tools, I believe. Oh, patch, that's what it is, patch. I'm going to patch this. Create a decent number of U and V spans, which is just splitting it up into via top and vertical and horizontally. And we can hit OK. And then it'll create the topography in a much smoother context. What you would have to do to cut out all this excess is basically draw a line, a multi-line around all this, select the multi-line and just type trim, and then select this excess, and it'll cut it down to just your topography. But that's what you can do in Rhino as well. So it works both in Revit and in Rhino. Rhino gives you a smoother outcome, but if you don't have Rhino, Revit works just fine. It's just a little bit harder to manipulate. Other than that, that is all I have for you fine people today. Thank you for watching. and I hope that you found this very helpful for your projects in the future.